Following on from the previous video, we got to this recurrence relation. So what it means is, suppose you have n number of blocks and currently your center of gravity is here. If you add an extra block in a special way, if you add it in a way such that it lines up with the current center of gravity, if you keep on building the structure in this way, so if you keep on adding an extra block, or make sure it lines up with the center of gravity, then if you keep on building the structure in this way, then two things will happen. One, the structure will never collapse, and the other thing is that, which we've seen in the previous video, the other thing is that it will lead you to this recurrence relation. So if you keep on applying this recurrence relation, then it also implies that the structure will never collapse. So if you apply this recurrence relation, so for one block, the center of gravity will be at 1. If you add an extra block, the next one will be a half. So you applying this recurrence relation will lead you to this. A third for 3 blocks. The center of gravity would be you adding an extra a third. For 4 blocks, it would be this, and so on. So this recurrence relation will generate this series. So this recurrence relation will generate this series. And you should recognize this series. This series, the harmonic series, it means that it keeps on getting bigger and bigger and bigger. It diverges. Remember the harmonic series? It keeps on getting bigger and bigger and it diverges. So what that means is that if you keep on adding blocks, your center of gravity will just keep on getting bigger and bigger and bigger and bigger. So you have the potential to go to infinity. And the other thing is, if you keep on adding blocks in a special manner, then the structure will never collapse. So from this recurrence relation, you know that the center of gravity can keep on getting bigger and bigger and bigger, and the other thing is the structure will never collapse. So this recurrence relation will generate this series, and we've seen this. The series, we've seen this in the past. If you try and sum up the series here, we don't know how to sum it up, but we know that it's always trapped between here and here, and we've seen this in the past. The way we did it, this is just me reminding you, you should already know this. So if you look at y equals 1 over x, it will generate this graph. So when 1 over 1, so this height here will be 1. Well, we deliberately create the width to be 1. So this area here would be 1. So this area, this rectangle here, would represent this. You should already know this. For 2, the height here would be, well, for 2, you put it into here, the height will be a half. So a half times a half times a width of 1. So this area here would be a half. That would represent this. And then for 3, you put it into here, that would be a third. So a third times the width of being 1. So this has an area of a third. That represents this. Well, all the rectangles here will be bigger. Oops, sound. All the rectangles here will be bigger than the integral of 1 over x dx. And this is just me reminding you. You should already know this. From here, you know that this thing here is trapped in between here and here. So what that means is that as n heads towards infinity, meaning, remember, n represents a number of blocks. If you keep on adding the blocks, natural log here will look like this. It will just get bigger and bigger and bigger. So this center of gravity will just keep on getting bigger and bigger and bigger. So what that means is that if you keep on adding blocks, then the center of gravity will just keep on getting bigger and bigger and bigger and bigger. So it has the potential to head towards infinity. We will continue from here in the next video. Okay.